ID, The Future, a podcast about evolution and intelligent design.
In 1980, influential paleontologist and evolutionary biologist Stephen Jay Gould wrote that we can know that evolution has happened by the imperfections and oddities that life shows. But is that true? And what if we took a closer look at those assumed evolutionary oddities and saw instead evidence of engineered elegance? Joining me today is retired geneticist Dr. Wolf-Ekkehard Lönnig to discuss his new paper reviewing the debate over the panda's thumb. Giant pandas have an elongated wrist bone, the radial sesamoid, that allows them to handle and eat bamboo with great dexterity. Some claim it's an imperfectly and inefficiently formed structure that is clear evidence of evolutionary processes at work. Others call it one of the most extraordinary manipulation systems in the mammalian world and clear evidence of engineering. So, which is it? Well, that's the topic of our conversation today. Now, in case you're not too familiar with the work of Wolf-Ekkehard Lönnig, let me share some details with you. Mathematician and ID theorist Granville Sewell has described Dr. Lönnig as an intelligent design pioneer. That's because for over 50 years, Dr. Lönnig has been offering robust criticism of Darwinian theory and advocating for intelligent design. He argued for intelligent design in his 1971 Masters of Science thesis at the Free University of Berlin. His faculty advisor there, the director of the Botanical Gardens and Botanical Museum of Berlin, Dahlem, had high praise for his thesis, saying this: "Finally, a master's thesis in which a young man turns decidedly against a sacred cow, neo-Darwinism, or the theory of descent in general, and demonstrates the sore points of a doctrine, which for most minds is thought of not just as a theory, as a great synopsis, but as an impeccable and almost completely proven fact." Wolf-Ekkehard would go on to earn a PhD from the University of Bonn and work as a geneticist for over 25 years at the Max Planck Institute for Plant Breeding Research in Cologne. He has continued throughout his career, and now in retirement, to criticize Darwinism and promote intelligent design in his writings, several of which have been published in scientific journals. Dr. Lönnig, welcome to the podcast. It's an honor to speak with you today.
Thank you very much for inviting me.
Now, you've written a paper recently reviewing the debate over the panda's thumb. And over a couple of episodes, I'd like to unpack what you've written, because I think it's an important example of the debate over evolution and the argument for intelligent design. Now, first, for those who are not very familiar with your work, can you share briefly about your scientific training and your career as a geneticist? How did your career prepare you to question Darwinian orthodoxy?
Yes, thank you very much for that very nice question. First, I would like to emphasize that a career in biology does not necessarily prepare you to question orthodox Darwinism. They do everything to keep you away from questioning Darwinian orthodoxy. However, studying the enormously complex biological facts that you are made familiar with, facts which are, on closer examination, often characterized by irreducible and specified complexity, can help you to question Darwinism. So I studied biology, including botany, zoology, genetics, and paleontology from 1965 to 1971 at the Free University of Berlin, as well as at the Universities of Mainz and Frankfurt. In the following years, I became a high school biology teacher. In 1978 and 79, there were the PhD studies and writing my PhD thesis at the Institute of Genetics at the University of Bonn. There, tasked among several others, teaching genetics for biology and medical students, internships, and also seminars on the history of biology and human genetics. Nevertheless, I would like to emphasize that you don't have to have a career in biology to doubt Darwinian orthodoxy. Any thinking person is capable to do this.
Those are great points, Dr. Lönnig. I especially like the one where you just said that you don't get taught how to criticize Darwinian orthodoxy, but the more you learn in your specialized field, the more you're able to understand the gap between the evidence and Darwinian theory. Those are great points. Well, let's give listeners an idea of what we're talking about today with the panda's thumb. Can you describe the giant panda's hand and how it differs from other bears?
Yes. Before I do that, I would like to state that in my following answers, for a lack of time, I will not always give the source of my quotations. Almost all the references can be found in my article on the panda thumb. Now, a short Wikipedia quotation. A thumb is visible on its forepaw, which helps in holding bamboo in place for feeding. The giant panda paw has an additional digit similar to a thumb and 5 fingers, so exactly 6 digits. A thumb and 5 fingers. It is the thumb-like digit which is so important, which helps it to hold bamboo while eating. So, to emphasize this point, the other species of the bear family do not have such an additional digit. And one can make a long discussion about the bones. I simply would like to show this picture. This is a thumb that you can see here. And this is digit 1, digit 2, 1, 2, 3, 4, 5. 5 and this thumb-like digit. So that special thumb has been cited for decades as a special proof for the theory of evolution. In fact, it has become really an icon of evolution. Darwinians have called it to be a crude structure. They have called it built from an odd part, clumsy, highly inefficient, imperfect, suboptimal, an example of bad design, and altogether an imperfection which no intelligent designer would ever have made, and only evolution by mutations and natural selection could have produced.
And I appreciate you sharing that image, because as you say, it really helps to kind of see what we're talking about here, and you can't always do that when it's audio. But thankfully, we're recording video, so we can see some of these visual aids. Well, the panda's thumb, as you're saying, has been a key example in discussions about evolution, particularly due to the well-known work of paleontologist Stephen Jay Gould. He formulated his argument for the panda's thumb in several books and works, pretty much over 20 years, starting in 1978, with a column that he published in Natural History through his summary of the argument in his magnum opus, The Structure of Evolutionary Theory, which he published in 2002. So let's spend a few minutes just talking about Gould's perspective. Why did he consider the panda's thumb to be an example of a striking imperfection or a clumsy but workable solution?
Yes. Gould has argued as follows. He said, we can know that evolution has happened by the imperfections and oddities that life shows. The panda must use parts on hand and settle for an enlarged wrist bone, and a somewhat clumsy but quite workable solution. The sesamoid thumb wins no prize in an engineer's derby. The panda thumb demonstrates evolution because, as all Gould, it is clumsy and built from an odd part, the radial sesamoid bone of the wrist. Gould also, the panda thumb is highly inefficient. If God had designed a beautiful machine to reflect his wisdom and power, surely he would not have used a collection of parts generally fashioned for other purposes. So far, quotations according to Gould. One may immediately ask after that, how did Gould know for sure what God would have done and what God would not have done? Interestingly, a group of researchers have pointed out recently the ailurids, it's a red panda, the tulpids, moles, the proboscideans, elephants, sigmodontine rodents, including New World rats and mice, and tenomid rodents, like tuco. They're all, in fact, they are some like structure understood to be a modified sesamoid. Now, this is 6 times independently in different groups of animals where this sum occurs. And then if evolution has produced it, it has 6 times independently made the same stupid mistake to take that wrist bone. There's recently a paper on the cotton rats, and their enlarged radial sesamoid bone and that of the giant panda have a similar morphology and size relative to the rest of the hand. So this would be convergence in evolutionary terms, 6 times, at least 6 times independently. And this is really, as Maya Moneymaker Nelson Seelge once said, convergence is a deeply intriguing mystery, given how complex some of the structures are. Some scientists are skeptical that an undirected process like natural selection and mutation would have stumbled upon the same complex structure many different times. And another biologist, here Henning Kahle from University of Bielefeld at that time, now it is precisely the phenomenon of convergence that poses further major problems for neo-Darwinism. For if the one-time emergence of completely adapted organs or characteristics through selection and random mutations can hardly be explained, the multiple formation of similar organs eludes the neo-Darwinian interpretation even further. So, evolutionists have a heavy problem with this at least 6 times independently arisen digits, although much smaller than in the panda in almost all cases. It is a problem for neo-Darwinism. But on the other hand, an intelligent course may reuse or redeploy the same module in different systems without there necessarily being any material or physical connections between those systems. Even more simply, intelligent courses can generate identical patterns independently, Luskin according to Nelson and Wells. An intelligent course, as I said, may reduce and redeploy the same module in different systems.
Yeah, and that is a great point. And convergence happens to be also very convenient to explain on the Darwinist's point of view how things came about seemingly independently multiple times. But it is definitely a mathematical and logistical problem for Darwinian theory. Yeah, we'll definitely include a link to your paper in the show notes for this episode. Now, that paper highlights that not everyone agrees with Gould's assessment. What evidence do you review in your paper, that contradicts the idea that the panda's thumb is suboptimal?
Well, first I would like to quote Paul Nelson, fellow of the Discovery Institute. He reports about his personal conversation with Gould the following points. He first asks, how did Gould know that this structure, the panda's thumb, was suboptimal? And then he said, so I asked Gould one-on-one, sitting in his office, what's the evidence that the thumb is actually suboptimal? And he said, Paul, just look at it. Just look at it. It is obvious. Nelson added, well, the fact is, it is not obvious. Every reference from the panda's natural history literature that I have found praised the structure in the highest terms, like a forceps. Schaller, with an utmost precision, Perry, etc. Richard Perry points out that pandas can hold a single piece of sugarcane or slice of bread. They can pick up a tin dish like a dog dish in their forelimbs.
Gould thinks it's obvious, Gould and others like him think it's obvious,
Yes.
but it's only obvious if you're coming from a bottom-up reductionist view of how organic systems emerge. If you're coming from the opposite end of the spectrum, a top-down designed approach, then it's equally obvious that it's an engineered masterpiece. So there's the rub. So for a layperson, it's one thing to talk about bones, but another to understand how they're used. Can you give us briefly some examples of the panda's dexterity when using its radial sesamoid?
Well, there's a Japanese evolutionary research group of Endo et al., and they commented the way in which the giant panda uses the radial sesamoid bone, its pseudo-thumb, for grasping, makes it one of the most extraordinary manipulation systems in mammalian evolution. They also said the radial sesamoid bone and an accessory carpal bone form a double pincer-like apparatus in the medial and lateral sides of the hand, respectively, enabling the panda to manipulate with great dexterity. Interestingly now, that's, I think, a very important point. Although evolutionary biologists who had spoken about the panda thumb as being crude, built from an odd part, being clumsy, highly inefficient, imperfect, suboptimal, and so on, which would be a mistake which no intelligent designer would ever have made, and only evolution by mutations and natural things would have produced. These same evolutionists, when they were watching the pandas more closely alive, they went to zoos and looked at that, and evolutionary biologists like Davis and Gould, both originally involved in the bad design argument, have confessed things like the following. Listen to Gould. I was amazed by their dexterity and wondered how the scion of a stock adapted to for running you could use its hand so adroitly. In plain English, he was amazed, astonished, surprised that a member of the bear family could use its 4 feet for both running and eating bamboo so perfect. The other is Dwight D. Davis. He had that famous big anatomy book about the panda thumb and pandas in general. He said he went to a zoo and then he reported the skill and precision with which objects are grasped and manipulated by the forefeet is astonishing. I have observed animals pick up small items like single straws and handle them with the greatest precision. Small discs of candy less than an inch in diameter were handled deftly and placed into the mouth. So I think it's so interesting that these leading evolutionary biologists who invented the story of the clumsy, inefficiency, imperfection, and so on, now when they saw it, they were enthusiastic how wonderfully these bears handled single straws and more. And I myself went to 2 different zoos and spent much time looking and studying them there. And I can only agree with Gould. And I can only agree also with David.
Yeah, as soon as you throw out the word clumsy, which is what Gould and others have done, it sort of paints that picture, of just the accidental evolutionary make-do sort of apparatus. But as you're saying, and as you're painting with words, it certainly doesn't seem that way when you're looking at these animals, when you're observing them. There's great dexterity and great precision as they handle small objects and sugarcane and even picking up dishes in various experiments. Well, in your paper, you quote molecular biologist Dr. Douglas Axe, suggesting that our inability to design such structures ourselves might disqualify us from judging their perfection or lack thereof. How does our lack of skeletal engineering influence our understanding of the panda's anatomy?
In 2017, Douglas Axe stated that none of these people, he speaks of the evolutionists, however earnest they may be, have any deep grasp of the principles of design and development underlying sesamoid bones and thumbs, to say nothing of pandas. Indeed, none of us do. And this is still true in 2025. Recently, Keogh et al. Have published a paper, analyses based on the function of false thumb in animals possessing false thumbs. And they state there are still a number of factors that cannot be explained, including the inability to fully explain the genetic mechanisms behind false fingers and the role of environmental factors and environmental factors that influence the growth of these structures. In the absence of this knowledge, the question is, how can evolutionists be so sure that the panda thumb is an example of bad design? And above all, how do evolutionists know that the panda thumb has been formed by many accidental, haphazard, random mutations, which have only slight or even invisible effects on the phenotype, to quote renowned Darwinian Ernst Mayr? Nevertheless, apart from this aspect of our so-called, we may call it the black box, so to speak, there's another, now already wide open box, namely what we can really see and study. And this, and so far, really and clearly understand.
Well, let's talk about the wrist connection next. We recall that the panda's thumb is actually an enlarged wrist bone called the radial sesamoid. Your paper mentions some debate that relates to the panda's thumb controversy between Bristol University bioengineer Stuart Burgess and Nathan Lentz, a professor of biology at the City University of New York. Now, Burgess has studied human skeletal joints like the wrist and the ankle and argues that they're masterpieces of engineering. Professor Lentz, he counters this view, asserting that the human wrist has 8 bones like a useless pile of rocks, he says. You know, you point to Burgess's expertise in engineering, and I think I want to dwell on that for just a second, just to show listeners and viewers how important his view is on this. When it comes to assessing the optimality of design in biological systems. I mean, Burgess is the real deal. He's a professor of engineering design. He has years of experience designing engineering systems, including bio-inspired designs. He's worked on Olympic bicycles. He's worked on spacecraft. He's done even work with the Hubble Space Telescope and some military satellites. So he knows complex systems. And I think that's the position you have to be in to really share insight on how difficult it is to create these things in a natural way or an unguided process, and just how much engineering is inherent in them. So what is Stuart Burgess's counter argument to Nathan Lentz, and how does it relate to the panda's anatomy?
I would first say that seeing that by the paradigmatic work of Burgess, all these speculations on superfluous human bones have scientifically been proved to be just what they are, entirely baseless evolutionary fantasies, to speak it frankly. The question may be raised now, could not the evolutionary ideas on the panda thumb also be entirely baseless evolutionary fantasies, to call that crude, clumsy, highly inefficient, imperfect, suboptimal, and so on? They ought to be contradicted by the biological facts. Could the panda's thumb not rather be a masterpiece of engineering, is the question. In a mail of 4th April 2024, Professor Stuart Burgess wrote to me, to quote in part, I had asked him to send me a quotable comment on that point. He said, as for the panda's thumb, it is of course an excellent design for the design objectives. When I read works by evolutionists on biomechanics, I am astounded by their lack of knowledge and ability to make sweeping and wild assertions. Because evolution predicts bad design, they, the evolutionists, impose their view of bad design despite the evidence.
A great quote there and a good way to remember it. Burgess saying to you, excellent design, speaking of the panda's thumb, for the design objectives. I think that's a key way to look at it. Here's my final question for today. Your paper emphasizes the dual function of the panda's hand, both for walking and for manipulating bamboo. How does this dual role potentially impact the design and efficiency of the thumb? Could a better thumb for grasping hinder the panda's ability to walk?
Now please imagine the enormous task to find a solution for one and the same organ, for so totally different functions as walking on it and help and being of help for eating. In the case of the panda, for walking through the bamboo jungles, and for eating by manipulating bamboo, it has to grasp, pluck, peel, strip, bite bamboo stems with the same organ. So in 2022, a group of Chinese and American researchers have made a great step forward into the scientifically correct direction by becoming clearly aware of the key significance of the dual function of the panda thumb. The authors state, among many other points, to adapt to life as a dedicated bamboo feeder, its extra thumb is arguably the most celebrated and yet enigmatic organ. In addition to the normal 5 digits in the hands of most mammals, the giant panda has a greatly enlarged wristbone, which we already heard several times, the radial sesamoid, that acts as a 6 digits and opposable thumb for manipulating bamboo. To the best of my knowledge, none of the evolutionists have ever critiqued the panda thumb as being crude, clumsy, highly inefficient, imperfect, suboptimal, and better. None of these people has ever suggested a better construction for that thumb. Probably because a better, totally different thumb for grasping would hinder the panda's ability to walk properly. On the other hand, one may not ask, why not the possibility of intelligent design? William Dembski and Michael B. have repeatedly emphasized that in our daily method to detect intelligent design, there is no magic, no vitalism, no appeal to occult forces involved. And indeed, inferring design is widespread, rational, and objectifiable. All of us, says Dembski, all of us are all the time engaged in a form of rational activity, which, without being tendentious, can be described as inferring design. Inferring design is a perfectly common and well-accepted human activity. People find it important to identify events that are caused through the purposeful, premeditated action of an intelligent agent, and to distinguish such events from events due to either law or chance. To repeat and to emphasize, there is no magic, no vitalism, no appeal to occult forces. Inferring design is widespread and rational and objectifiable. And at the beginning, I mentioned 2 points, namely irreducible complexity and specified complexity. And these are methods which have been successfully applied to such questions.
Yeah, that's really good, and and a good reminder that the appeal to design is not an appeal to occult forces, as Dembski's pointing out, or magic. This isn't magic we're saying is doing this, or we're proposing. This is information coming from a mind, and that is something that can positively produce the information that is necessary to explain infusions of new biocomplexity and this is something that makes sense, not on a magic level, but as a mechanism that is capable of doing what we say it does. So, yeah, those are great points. Well, I think we need more time to unpack the insights you provide in this paper about the debate over the panda's thumb.
May I please interrupt you? I have one little point.
Absolutely.
Which I would like to add. I would like to add that there is a massive contradiction within the theory of evolution itself. Because Darwin asserted natural selection is daily and hourly scrutinizing throughout the world every variation, even the slightest, rejecting that which is bad, preserving and adding up all that is good, silently and insensibly working whenever and wherever opportunity offers at the improvement of each organic being in relation to its organic and inorganic conditions of life. Nowadays, evolutionary researchers like Professor John Avis assert natural selection comes close to omnipotence. Professor Christopher Exley is indeed convinced that both the beauty and the brilliance of natural selection are reflected in its omnipotence to explain the myriad observations of life, virtually in agreement with Dawkins, Coyne, Futuyma, Dodd, Ayala Meyer, and many other renowned evolutionary authors. Or take Nobel laureate François Jacob. The genetic message, the program of the present-day organism, resembles a text without an author that a proofreader has been correcting for more than 2 billion years, continually improving, refining, and completing it. Now the important point, he continues gradually eliminating all imperfections. And now, on this background, as a result of this unlimited, omniscient, omnipotent natural selection, gradually eliminating all imperfections, now this crude, clumsy, highly inefficient, imperfect, suboptimal, and bad design of the bundle thumb ? This is, I think, it's really a massive contradiction within the theory of evolution itself.
Well, in part 2, we'll discuss what you refer to in your paper as the optimal panda principle and how this differs from Stephen Jay Gould's argument. We'll also consider why proponents of evolutionary processes haven't offered any alternative designs for this seemingly imperfect and clumsy wrist bone in giant pandas. And then we'll delve a little into the genetic aspects of the panda, allowing us to question whether natural selection can really be credited for the seemingly coordinated development of complex features like the panda's thumb. In short, we'll continue to probe our central question. Is there evidence that the panda's thumb could be, in fact, a well-engineered system, tailored to the panda's specific ecological niche? Well, Dr. Lönnig, thank you for your time. I look forward to continuing this conversation in our next segment.
Thank you very much for interviewing me.
Well, as I said in the show notes for this episode, always available at idthefuture.com, we'll include links to Dr. Lönnig's paper on the panda's thumb, as well as a link to his website, where you'll find detailed listings of his research and his publications. That's going to be at idthefuture.com and in the description for this particular episode. And if you enjoyed the content on today's episode, please consider sharing it with a friend and leaving us a 5-star review on Apple Podcasts or Spotify. And as always, reach out to me with comments or episode suggestions at andrew@idthefuture.com. That's andrew@idthefuture.com. Well, this is Dr. Lönnig. I'm Andrew McDermott. For ID the Future, thank you very much for tuning in.
ID the Future, a podcast about evolution and intelligent design.